In any number system, if you are adding two numbers, let us say they are n digit numbers, then the result can be as big as n plus 1 digits. For example, in worst case, if you add two digit decimal numbers like this, if you add 99 plus 99, how big could be the result? 18198, right? Which means if I add two digit numbers, then the result could be as big as 3 digit. And similarly, you can even do in binary. In binary, if you are going to add two 4-bit numbers, 1 1, let's say 0 0, then how big could be the result? 0 0 1 1 0, right? So two 4-bit numbers I am adding, and in worst case I might get 5 bits. Now when I am doing this addition on board using this marker and the board, then there is no problem of overflow. So even if you are getting one more digit here, right, and one more digit here, we have enough space to write there. But in computer, when you are doing the arithmetic in a computer, the sizes of the registers are fixed. Therefore, whenever you get extra bit, for example, if you are adding two 8-bit numbers in registers, and if the result has to be stored in an 8-bit register, if the result happens to be 9-bit, then that extra bit is going to be called as overflow. But then carry does not always indicate overflow. So observe this. Now we are talking about overflow. So overflow is a condition in which the result cannot be fit into the space that we are given. Again, overflow is a condition in which the result cannot fit into the space that we are given. For example, if you are adding two 8-bit numbers, if the result happens to be 9 bits, we cannot fit it there. But then a carry always does not indicate overflow, which means whenever we get a carry, we cannot directly say that there is overflow. There are conditions, we should analyze them. So let us say we are talking about unsigned numbers first. Unsigned numbers means only positive numbers. In this case of positive numbers, a carry will indicate the overflow, right? So let's discuss about it with some examples. Assume that we have 4 bits. With 4 bits, what is the range of the positive numbers that we can represent in binary? The range of the positive numbers can be 0 to 2 power 4 minus 1. This is the range of the unsigned number that we can represent, which is nothing but 0 to 15, right? Now let us assume that I am adding these two numbers, 1 0 0 0, and yes, we can add this one only, 1 1 0 0, right? So what is this? This is 8, this is 12. So what is 8 plus 12? 8 plus 12 is 20. But then in 4 bits, how big a result we can store? Only 15. Therefore, if you add them, the result is going to be 1 0 1 0 0, isn't it? Yeah, 1 0 1 0 is 10, 1 0 0 is 20. So if you add this, the result is going to be this big. Therefore, in case of an unsigned number, whenever you get carry out of the most significant bits, from here if you get a carry, then this case indicates overflow. But then this is not true in case of signed numbers. But before going for signed numbers, we shall see one more example. Let us say I am going to add 1 0 1 0, which is 10, and then 0 1 1 0, which is 6. What should be the result? Result is going to be 16. But then how big number we can fit in this? 15 is the largest number that we can fit in 4 bits, but now we got 16 as the output here. Now let's see what happens. 0 1 1 is 1 0, 1 1 is 1 0, 1 1 is 1 0, right? Therefore there is a carry generated. So carry in case of unsigned numbers is going to be a problem, and it is called overflow. Got it? So in case of unsigned numbers, always carry indicates overflow. Now let's see what happens with this in case of signed numbers. Signed numbers means we represent both positive numbers and negative numbers. Let's go to 2's complement and work on that. 2's complement number. So in case if this happens to be 2's complement number system, let's see what does these numbers represent. In 2's complement number system, what is the maximum 4-digit number we can represent? What is the maximum 4-digit number? What is the range of numbers that can be represented in 4 digits? Using 4 digits, in case of 2's complement, what is the range? I think you remember that the range is minus 2 power n minus 1, which is 3 to 2 power n minus 1 minus 1. So what does it mean? Minus 8 to plus 7 is the range that we can represent in this. Now if anything occurs beyond that, then we cannot represent it, right? Now let's see what these numbers represent in 2's complement. Now 1000, this one represents minus 8. This particular number represents minus 8 in 2's complement. And similarly 1100, this one represents minus 4 in 2's complement. Okay, so how minus 4? Because it is minus 8 plus 4, it is minus 8, that is why minus 8. Minus 8 plus 4 is minus 4. Now what should be the result? The result has to be minus 12. That has to be the result, right? But then can we hold minus 12 in this 4 digits in 2's complement? We cannot hold it because minus 8 is the maximum number that we can hold. Therefore, if you look at the result will be 10100. This is the result. And what is this result representing 2's complement? Check this. This is nothing but minus 16 and this is nothing but plus 4. Minus 16 plus 4 is minus 12. Therefore, there is clearly an overflow, isn't it? So here in this case, the carry indicates overflow. Got it? But then in all the cases, carry might not indicate overflow. For example, you can look at this example. 1010 0110. Let's see what happens here. So here it is minus 8 plus 2, which is minus 6. This number represents minus 6 and this one represents plus 6, right? So minus 6 plus 6 is going to be 0. Now if you add them, it is going to be 0 0 0 0 1. So even if you ignore this carry, this is the result which we wanted. So even though carry is generated, this does not represents any overflow. Therefore here there is no overflow, but here there is overflow. Therefore in case of signed numbers, a carry does not necessarily mean that it is a overflow. So we cannot use this logic. We cannot use the logic of saying that if there is carry, there is overflow, right? Then what is the other logic we can use? Watch it clearly. So in case of signed numbers, most significant bit indicates the sign of the number. And since it is 1 and it is 1, both of them are 1s, they indicate that it is negative number. It is a negative number, it is a negative number, right? And since both of them are negative, we can say that see, both of them are negative here. Since both of them are negative, the answer has to be negative. But then if you look at this bit, the most significant bit, if you consider only for 4 bits, see, if you consider 5 bits, the answer is minus 12 and it is right. But then we are supposed to consider only 4 bits because we are assuming that we have only 4 bits to store the result. That is the assumption. Now, if you are having only 4 bits, if you see this, 2 negative numbers are added and the answer turned out to be positive, which is completely false. Therefore, this is the indication for overflow. What is the indication for overflow in signed numbers is whenever we are adding 2 negative numbers, answer has to be negative number. But here we are adding 2 negative numbers, but answer is a positive number. Therefore, we can say that it is a overflow condition, right? And now here, whenever we are adding a negative number and a positive number, there will be no overflow. That is the condition. So remember this. Whenever we are adding 2 negative numbers, answer has to be negative, and whenever we are adding 2 positive numbers, then answer has to be positive. So let's take one example there and see it. Let us say 0 1 1 1 and 0 0 0 1. This is the number which I wanted to add. Okay. Now if I add them, what is the answer I get? 1000. there is no carry at all. There is no carry out of the most significant bit. So if there is carry, it may or may not mean overflow, and if there is no carry, then also it may or may not mean overflow. So see this one here. In this one, if you expand it, if you convert it to 2's complement, this number is nothing but plus 7 in 2's complement, and this number is nothing but plus 1 in 2's complement. Now if you add both of them, it has to be plus 8. But look at the range of positive numbers that can be represented by 2's complement number. 7 is the largest number that you can represent, but here we got 8. What does it mean? It means that there is again overflow here. See, what is overflow? If the result cannot be represented in the given number of bits, then that is overflow. Given number of bits is 4 and the result is 8. I cannot represent it, therefore it is overflow. But then it does not generate any carry. Therefore, you cannot depend on carry in case of signed numbers, right? Now check this one. So how can we say that it is overflow? Again, using the same logic. What is it? When two positive numbers are added, if the result turned out to be negative, we can say that there is overflow. Got it? When two negative numbers are added, when the result turned out to be positive, it is overflow. When two positive numbers are added and result turns out to be negative, then it is overflow. So can we say that always if there is no carry, there is overflow? We cannot say that again. Therefore, we cannot depend. I'll just give you an example. See, this is an example in which when we get a carry, there is a overflow. This is an example in which when we get a carry, there is no overflow. This is an example in which when we don't get a carry, there is an overflow. Now I'll give an example in which we don't get a carry and there is no overflow. Okay, so see this. Let us say 0 0 1 1 and then 0 1 0 0. So what is the number? This one, this is 3, this is 4 in 2's complement, and when I add it, the result has to be 7, and 7 happens to be in the range of numbers that can be represented using 4 bits. Therefore, there should not be any overflow. Check this. 0 1 1 1. So now there is no carry, and when I added two positive numbers, I got a positive number, and there is no carry, and it is actually no overflow. Got it? So here we cannot depend on the carry. We have to look at these rules. So what are the rules? So the rules are this. Rule number 1. I am just writing the rules in case of unsigned. So in case of unsigned numbers, carry always indicate overflow. This is unsigned numbers, right? In signed numbers, overflow is indicated by two cases. What are the two cases in which overflow is indicated? Case number 1 is when two positive numbers are added then result is negative. This is a condition for overflow. And the second condition for overflow is when two negative numbers are added and the result is positive. So these are the two conditions where we get a overflow. Therefore, in unsigned numbers this is the condition, and in signed numbers this is the condition. Okay, so remember this. And a very important note here, note it down. Carry does not indicate overflow in case of signed numbers. Carry does not indicate overflow. Okay, so now always checking these 3 bits. So what is the sign of the 2 inputs and an output? Instead of checking these 3 bits, there is a shortcut using which we can decide whether there is overflow or not very quickly. I'll tell you that method now. Okay, so instead of comparing 3 bits in order to find out if there is overflow or not, people have found out an easy method. to compare 2 bits and find it out, because 3-bit comparator is bit difficult to, is bit complex compared to 2-bit comparator, right? So see, the method is simple. What is the condition for overflow in signed numbers? Whenever you have two negative numbers, if the answer is positive, it is overflow, and whenever you have two positive numbers, if the answer is negative, then it is overflow. So we have to check the most significant bit of these two numbers as well as of the result, but it is going to be complex because we need 3-bit comparator. Now instead of that, what if we could do it using 2-bit comparison, right? So how it can be done is follow this. Let us say we are adding two 4-bit numbers, A3, A2, A1, A0 is one 4-bit number, and similarly B3, B2, B1, B0 is the other 4-bit number. Okay. Now whatever carry we get from this stage, means whatever carry we get into this stage, let's call it as C in, and whatever carry we get out of this stage, let's call it as C out. Okay, so we are going to get some carry into this and we are going to get some carry out of it, so we call this as C in and C out. So what is C in and C out here? Whatever carry we get into the most significant bits here, the most significant bit stage, that one I am calling it as carry in, and whatever you get out of it I am calling it as carry out. Now I am assuming that so if this is the carry in and carry out are the assumptions. Now whenever carry in is equal to carry out, so check this. So in this case, what is carry in? Carry in is 0 and carry out is 1. So whenever carry in is not equal to carry out, okay, we can say that there is overflow, and whenever carry out is equal to carry in, then there is no overflow. Check all those examples and I'll tell you the reasons why this is so. First check the examples, I'll tell you the reason. See this one, the first example, there is overflow. So what does it mean? Carry in should not be equal to carry out. So check this, what is the carry inside these bits? If you are looking at it, the carry inside this into these bits here. So from this stage, the carry into getting into is 0, right? What about the carry coming out of it? Carry coming out of it is 1. So both are not equal, and so there is overflow. It is simple logic, right? And what about this one? See this. So here 1 and 1 are added, therefore 1 0, and 1 and 1 are added, therefore 1, which means carry going into it is 1 and carry coming out of it is 0, which means carry in is not equal to carry out. Carry out is 1. So carry in is equal to carry out, therefore no overflow, right? So whenever carry in is equal to carry out, there is no overflow. Now check this one. So what is the carry going into this? So if you are adding this, 1 plus 1 is 0, and then 1 is 0, and then 1, you get 0 here, and then 1. So which means carry going into it is 1 and carry coming out of it is 0, which means there is no carry produced here. So carry in is not equal to carry out, therefore there is overflow. Now what about this one? See this. Now the carry going into this, the carry going into is 0 and the carry coming out of it is 0. So carry in is equal to carry out, carry in is equal to carry out, therefore no overflow. So I think this method is working for all the examples, for all the cases. Now let's see why should this method work at all. Okay. Now let's see how overflow is possible. Now I am saying that let us assume that these are the two bits of the MSB, and let us say there is some carry coming in and there is some carry coming out. Now when will there be overflow? There will be overflow if carry in is 1, if the carry coming inside is 1 and the carry coming out is 0, then only there will be overflow. Now let's analyze how is it possible. So how is it possible that if the carry going in is 1, we don't get a carry outside? So this is possible only when these two are 0 and 0, right? If these two are 0 and 0, and if you are giving the carry as 1, what does it mean? Then the most significant bit of the result will be 1 and the carry will be 0. What does it mean? We are adding two positive numbers and the result is negative. That is why there is overflow. I hope you understood this case, right? And similarly, let's analyze the other case. What is the other case? When the carry in is 0, if the carry in is carry out is 1. Let's see when this is possible. If carry in is 0, when will the carry out be 1? Only when the most significant bits are 1 and 1. Then what happens? Then the most significant bit of the result, most significant bit of the result will be 0 and the carry will be 1. What does it mean? When we are adding two negative numbers, the result happen to be positive, right? Therefore, in this case, again we get a overflow. Two negative numbers are added and we got one positive number. If you understood this logic, it is fine. If you didn't understand this logic, then what you should do is, okay, if you didn't understand this logic, then what you just remember this like this. Okay, these two formulas you remember it. If you understood the logic, it is okay. Now let's see the other case. What is the other case? The other case is when there will be no overflow. So there will be no overflow if carry in is equal to carry out, which means if the carry in is 0 and the carry out is 0, right? So when will these cases be possible? These cases will be possible whenever it is either 0 1 or 1 0 or 0 0, right? So what does it mean? We are adding one negative number and one positive number, and one negative number. Therefore there will be no overflow at all. One negative number and one positive number, there will be no overflow at all. We are adding two positive numbers and the MSB of the result is also 0, therefore there will be no overflow at all. And the second case is when the carry in is 1 and carry out is 1. When will this case be possible? When will this be? When carry in is equal to 1, when will the carry out be equal to 1? So it will be possible only when we have 1 1 here, 0 0 0 1 0 and 1 1, which means when we add two numbers of opposite signs, then it is possible. Or when we add two negative numbers, right, then the result of the MSB of the result will also be 1, right? Therefore negative number when added, we are getting negative number, and in these two cases anyway we don't get any overflow. So if you understood the way I analyzed it, it is fine. If you didn't understand what I said, then just remember these formulas. I think this is somewhat complicated to analyze, understand it. If you didn't understand it, forget it. Just remember that as if it is a formula. Okay. So what is the formula here? Now why did we derive this? Because we don't want to compare 3 bits. We just want to compare 2 bits, and we have to we wanted to find out it. So what is the advantage of it is we can use the exclusive OR. So now what will indicate this overflow is exclusive OR gate. Now you can put an exclusive OR gate, and to this exclusive OR gate you can put carry in and then carry out, and this one will go to the overflow flag. So every processor will have in process status word, right? In that status word we are going to have something called as overflow flag, which indicates that the result has overflow. Now whenever these two are not equal, right, whenever it is 0 1 or 1 0, this one will generate a 1 as the output, and that one will be stored in the overflow flag. So whenever you are doing these arithmetic operations, this simple logic can be used to generate that overflow flag, and depending on the overflow you can know that the result is overflown or not, and depending on that you will take the corrective measures, right? Okay, so this is how you can handle the overflow, right? Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177, and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.